Hello student, welcome in a ROSE project. This ROSE project is conducted by Ray Shikshan Samstha Sadguru Gadge Maharaj College, Karad. Myself is Jagtap PS. My subject is physics. The topic number 6, superposition of a wave. In this topic, we discuss lecture number 2 of superposition of a wave. Content of the topic is amplitude of the resultant wave produced due to superposition of two waves. Stationary wave, formation of a stationary wave, equation of a stationary wave on a stretched string. First point is the amplitude of the resultant wave produced due to superposition of two waves. Consider two waves having the same frequency but different amplitude, A1 and A2. Let these waves differ in phase by phi. The displacement of each wave at x is equal to 0 is given as two equations. Y1 is equal to A1 sin omega t. Y2 is equal to A2 is equal to A2 sin omega t plus phi. According to the principle of superposition of the wave, resultant displacement x is equal to 0 is y1 is equal to y2. Then put this value of y1 and y2 in equation. Then equation get y is equal to a1 sin omega t plus a2 sin omega t plus phi. An expansion of sin omega t plus phi is the sin omega t cos phi plus cos omega t sin phi. Then equation become y is equal to a1 sin omega t plus a2 sin omega t cos phi plus a2 cos phi sin phi. Then two equations get common sin omega t, the first and second term. Then in bracket a1 plus a2 cos phi remain, and second term is a2 sin phi cos omega t. If you write a1 plus a2 cos phi is equal to a cos theta and a2 sin phi is equal to a sin theta, then above equation becomes y is equal to a cos theta sin omega t plus a sin theta cos omega t. Therefore, y is equal to a sin omega t plus phi. This is the equation for resultant wave. It has the same frequency as that of the entire wave. The resultant amplitude A is given by squaring and adding equation 6.4 and 6.5. Then we get a square cos square theta plus a square sin square theta is equal to in bracket a1 plus a2 cos phi square plus a2 square sin square theta. In this expansion of this bracket is a1 square plus a2 a1 a2 cos phi plus a2 square cos square phi. This is the expansion for a1 plus a2 cos phi. Then a2 square cos square phi is equal to, take the square root of both sides, then we get a is equal to root a1 square plus 2a1 a2 cos phi plus a2 square. Then this equation is the resultant amplitude given by this equation. Next is a special case. There are two special cases. First case is when phi is equal to 0. That means the wave are in phase. The resultant amplitude is A is equal to root A square A1 square plus 2A1 A2 cos theta plus A2 square, and cos 0 is equal to 1. Therefore, this is the expansion for A1 plus A2 square. Then root and square cancel to each other. Therefore, A is equal to A1 plus A2. The resultant amplitude, this is the resultant amplitude and is a maximum when phi is equal to 0. If the amplitude of the wave are equal, that means A1 is equal to A2 is equal to A, then the resultant amplitude is 2A. Then the resultant amplitude is 2A. This is about the first case. And in second case, when phi is equal to pi, that means the wave are out of phase. The resultant amplitude is, then put the value of phi is equal to pi, then we get this equation. A is equal to under root A1 square plus 2A1 A2 cos pi plus A2 square, and this is the expansion for A1 minus A2 square. This root and square are cancelled to each other, then the resultant amplitude A is equal to mod A1 minus A2. This is the resultant amplitude is a minimum when phi is equal to pi. If the amplitude of the wave are equal, that means A1 is equal to A2 is equal to A, then the resultant amplitude is 0. This is about the two special case. Okay. Next, thus the maximum amplitude is the sum of the two amplitude when the phase difference between two waves is 0, and minimum amplitude is the difference of the two amplitude when the phase difference between the two waves is a pi. Next point is a stationary wave. Superposition of wave having the same amplitude and the same frequency traveling in opposite direction. When two identical waves traveling about same path in opposite direction interferes with each other, the resultant wave is called as the stationary wave. Means there are two waves of the same path in opposite direction, and this wave is called as the stationary wave. The intensity of the wave are proportional to the square of their amplitude. Hence, when phi is equal to 0, maximum intensity is given, and this maximum intensity is directly proportional to the maximum amplitude square and is equal to A1 plus A2 square. And second, when phi is equal to pi, minimum intensity is get, and this is directly proportional to the minimum amplitude square and is equal to A1 minus A2 square. Therefore, intensity is maximum when two waves interfere in phase, while intensity is minimum when two waves interfere out of phase. Next point is the formation of a stationary wave. Imagine a string stretched between two fixed points. If the string is pulled at the middle and released, we get what is known as a stationary wave. Realizing of a string produced two progressive waves traveling in opposite direction. These waves are reflected at the fixed end. The wave produced in the string initially and their reflected wave come to produce stationary wave is shown in figure. This is the figure for formation of stationary wave on a string. There is a two portion. This portion is called as the antinode, and their maximum intensity, this is the called as the antinode, and zero intensity is called as the node. The equation of stationary wave on a stretched string. Consider two simple harmonic progressive waves of equal amplitude A and wavelength lambda producing on a long uniform string in opposite direction. Remember that 2 pi divided by lambda is equal to k and 2 pi n is equal to omega. The equation of the wave traveling along the x-axis in the positive direction. Then equation first is a y1 is equal to a sine 2 pi nt minus x divided by lambda. The equation of the wave traveling along the x-axis in the negative direction is y2 is equal to a sine 2 pi nt plus x divided by lambda. When this wave interferes, the resultant displacement of the particle of string is given by principle of superposition of a wave. Then y is equal to y1 plus y2. Put this value of y1 and y2. Then equation become y is equal to a sine 2 pi nt minus x divided by lambda plus a sine 2 pi nt plus x divided by lambda. By using this formula, sin c plus sin d is equal to 2 sin c plus d divided by 2 into cos c minus d divided by 2. Then we get y is equal to 2a sin 2 pi nt cos 2 pi x divided by lambda. Then next equation is y is equal to 2a cos 2 pi x divided by lambda and sin 2 pi nt. In this equation, we put the values of 2a cos 2 pi x divided by lambda is equal to a if in equation 6.12, then we get y is equal to a sin 2 pi nt. Where omega is equal to 2 pi n, we get equation is equal to y is equal to a sin omega t. This is the equation of stationary wave which give resultant displacement due to two simple harmonic progressive waves. Next is a condition for nodes. The nodes are the point of a minimum displacement. This is the possible if amplitude is minimum, that means 0. The amplitude is 2a cos 2 pi x divided by lambda is equal to 0. Then cos term is 0, means cos 2 pi x divided by lambda is equal to 0. When 2 pi x divided by lambda is equal to pi divided by 2, 2, 3 pi divided by 2, 5 pi divided by 2, where x is equal to lambda divided by 4 and 3 lambda divided by 4, and next is the 5 lambda divided by 4 dash dash. That means x is equal to in bracket 2p minus 1 into lambda divided by 4, where p is equal to 1, 2, 3 dash dash. The distance between two successive nodes is a lambda. This is about the condition for nodes. Next is the condition for antinodes. The condition for antinode is antinode are the point of a maximum displacement. That means a is equal to plus minus 2a. The a is equal to 2a cos 2 pi x divided by lambda is equal to plus minus 2a. Then cos theta, that means cos 2 pi x divided by lambda is equal to plus minus 1. Then this theta 2 pi x divided by lambda is equal to 0, pi, 2 pi, 3 pi dash dash In this case, cost term is a 1. Or when displacement is 0, pi by 2, or lambda, 3 lambda divided by 2, dash dash. X is equal to lambda into p divided by 2, where p is equal to 0, 1, 2, 3, dash dash. The displacement between two successive antinodes is a lambda divided by 2. The displacement between two successive antinodes is a lambda divided by 2. Nodes and antinodes are formed alternately. Therefore, the displacement between the node and adjacent antinode is a lambda divided by 4. Okay, this is the two conditions for node and antinode. Next point is when sin omega t is equal to 1. At that instant of time, all the particle for which cos kx is a positive have their maximum displacement in positive direction. At the same instant, all the particles for which cos kx is negative have their maximum displacement in negative direction. When sin omega t is equal to 0, all the particles cross their mean position, same of them moving in a positive direction and same in the negative direction. And in a longitudinal wave, that means, for example, sound wave travel in a tube or pipe of a finite length are released at the end in the same way as transverse wave along a string are reflected at the end. The interference between these waves traveling in opposite direction gives rise to standing wave are shown in figure. This figure. Okay. We represent longitudinal stationary wave by a loop, but actually motion of the particle is along the length of the loop and not perpendicular to. This is the figure for left side show standing wave in a conventional way, while figure on a right side show actually oscillations of the material particle for a longitudinal stationary wave. Point A and N denote the antinodes and nodes respectively. In this figure, this portion is the antinode, this is node, antinode and node. Okay. Thank you.